Okay. So in today's class, we are going to discuss the the latest start and latest finish, the continuation of the problem which we had stopped yesterday, and from there we are going to discuss how much delay uh, each of the activities will be having. Right? What would be the allowable delay the each of the activity will have? That will be discussed in today's class. Okay. Uh, okay. So what was the last point that we have discussed in yesterday's class?
Interpretation, sir.
Okay, interpretation of have we solved extra problem on latest start and latest finish?
We have solved
We have
two
solved two
problems.
problems, sir.
Uh, okay, so we have solved two problems on latest start and latest
Yes.
finish. Correct?
Yes, sir.
Okay, and we have also written the interpretation. Is it right?
Yes, sir.
Okay, so the interpretation was that the project manager can start the activity anywhere in between the early start and latest finish. Is it right? Is it right? So have we discussed this particular
Yes, sir.
okay. All right. In today's class, basically, like right now, what we have discussed was we have seen what is early start, and also we have determined what is the latest start for each of the activities. Correct, and early start and the latest start, and what is the allowable time for the project manager? How much for uh, uh, in what range of duration an activity can be started, that also was determined in the previous. Correct. So in today's class we'll discuss the total delay available for each of the how much an activity can be delayed. Okay, so that is basically the discussion today. Okay, floats is going to be the next topic. So before that, you can just write the heading as float. Okay, what do we mean by float is that floats are nothing but it is basically the delay, allowable delay for each of the activity. That means what how much an activity can be delayed instead of starting on a early start date. How many for how many days we can actually delay an activity in such a way that the project completion duration will not be altered. Project completion duration will be 40 days or 50 days, whatever it was, like what we had determined earlier. Correct, and without affecting the project completion duration, how are we going to delay the activities, or for how many days we can actually delay an activity? That is basically the question. Floats are allowable delay for each of the activity. Okay, so there are three types of floats. There are three types of floats. They are total float, free float. Okay. One more is just a minute. Can be interfering. Just let me confirm on this. So we will see what exactly does total float and free float mean. Okay, and the third one is interfering float. So these are the types of floats. Okay, is it fine? These are the different types of floats. So first thing is we have to know is how many active or how many days an activity can be delayed, and that is without affecting project completion duration. And the next thing we should know is what are the different types of floats. There will be again different types of floats apart from these, but for our syllabus, so we are only discussing total float, the free float, and the interfering float. Okay, so we will see one by one. In general, can you just tell me what is the for how many days can we actually postpone an activity, or how to determine the total delay available for each of the activity? Can anyone tell what can be the equation for determining the total delay for an activity, total allowable delay for an activity? I think it is very easy answer. I think nothing much equation wise. It's not much complicated. Possibly, if you have already understood the early start, early finish, latest finish, then you can easily determine what is the total float or the total delay available for each of that. Can anyone tell how to determine using early start, early finish, latest finish, how to determine the total delay available for each of the activity? Any idea as to how to determine the total delay available for each of the activity using early start, early finish, latest start, and latest finish? Okay, possibly not many of them are getting any idea. Um, we'll see how to solve it. Uh, just check how to determine the total float. Okay, so total float. First concept is the total float. The total delay is calculated as uh, the latest start for an activity minus early start for an activity. All right. So does everyone agree to this? Or it can also be late finish for an activity minus early finish for an activity. Is it fine? So this is the equation to determine the early start and the latest start for each of the activities. Okay. So this is the equation for the total float. Total float means what? It is the total delay available for an activity. This is the total delay available for an activity. The project manager can easily consume this. Okay. And by consuming this particular delay, the project completion duration will not be postponed. And that is the meaning of total. Okay, so I'm going to the next screen. Yes. So by consuming the total float of an activity, the project completion duration, the project completion duration will not be postponed. Okay. So if the project manager actually consumes the total float of an activity, then the project completion duration will not be postponed. Okay. So this is the flexibility what the project manager has. Okay. So this is the flexibility that the project manager has. Okay. Is it fine? So it is good if the delay is available for each of the activity. It's a very positive sign for the project manager so that there will be some sort of a relaxation available for the project manager in order to complete each of the activities in the project. Otherwise, what will happen is there will be a very tight schedule. And in this particular tight schedule, the project manager is supposed to complete each of them. If the float is available, that will not happen. Okay. Okay. So just make note of this. And simultaneously, can anyone tell such an example for which we have solved both the latest start and the latest start, latest finish, and early start and early finish? Is there any problem for which we have completed both early start, early finish, late start, and late?
Previous problem, sir.
No, not the previous one. So I think the previous one we'll keep it as a practice problem. Before that, did we complete any problem uh, for which we have completed both early start and early finish, latest start and latest? So that quickly we'll start with total float calculation.
The first problem was taken as like the previous early start problem itself, sir. We have
Okay.
not calculated separately early start, but
That
the early
was
start for that problem was calculated before.
before. Okay. So we'll consider the same problem. In that case, just tell me the activity list. So we'll write it as an example one activity duration. So I want early start of that activity, early finish of that activity. Late start and late start and late finish, and final last column. We will write this separately. First, we'll write only the question statement. All right. So give me the list of activities, duration, early start, early finish, latest start, and latest.
1 to 2,
How many activities are there in total?
5,
Then we write it in. Okay.
2
1
to
dash
3,
next
3-5,
3-5. Okay.
2-4,
Okay.
4-5,
4-5. Okay. So next duration.
7,
Okay.
10,
Okay.
4,
Okay.
15,
Okay.
5,
Next.
0,
Early start is 0. Okay. Next.
7,
7,
17,
17, 7,
7, 22,
22. Duration
7,
7, 17, 21, 20,
17, 21,
22, and 27. Okay. Latest.
0,
Uh, uh,
latest finish,
okay. Latest start the 0. Next.
13,
Uh,
23,
hmm.
7, 22,
Latest.
7,
Okay.
23, 27, 22, and 27.
Now for this problem, we are supposed to determine the total float. So let's see how to determine the total float problem. Just make note of this table. Question is, determine total float for each activity. Determine total float for each activity. That is the question. Okay. Determine the total float of the activity. So this is the question. Now for 10 marks, they may ask you to determine all these components: early start, early finish, latest start, latest finish, and total float. So for 10 marks, this type of problems are possible. So here you need to write a little bit fast. So you have to solve the problems a little bit faster and simultaneously also see that the problems are solved. Okay, so can anyone tell what is the total float for the first activity? Total float means what is the total delay available for the first activity? By how many days we can delay the first activity?
7.
First activity. What is the equation for the total float?
Early finish minus early start.
Total float. What is the equation?
Late finish minus early finish.
Late finish minus early finish, correct? Or late start minus early start. Is it right? So in that case, what will be the first total float?
7
Zero.
minus 0.
0.
0.
7 minus 7, 0.
7
Seven,
minus 7. And that will be 0. Why? What is the interpretation of this? It means that there is no delay at all for this particular activity, and the project manager has to start this activity on the first day itself. Okay, there is no point in delay in this activity. This is the first activity. Project manager has to start this activity on time. Okay, that is on 03. All right. So we'll start writing the solution. So just seeing if the same screen can be copied once again. Instead of writing this once again, what I will do is write solution. So exercise, this question you have written, is it right? Now, since I do not want to write this once again, so what I will do is I will continue in the same table. Or else I will write it separately. Example 1. Consider this as example 1. Write it on the screen. Okay, so it will be. So total float for activity 1-2 is equal to latest start minus late early that is equal to 0 minus 0, which is equal to 0. Similarly, what will be the total float for the second activity?
10.
Okay, what is second activity? Total float for activity in the table, which is the second one?
2-3.
2-3. Okay, so again the same equation, late start minus early start. What is the answer?
So 6.
How? How 6? What is the calculation here?
30.
How much?
13 minus
13
7.
minus 7.
13 minus 7, which is equal to 6. Okay. So we'll write the interpretation for this and we'll go ahead. Yes, that's right. 13 minus 7, which is equal to 6. So we'll write the interpretation. Then you can continue the calculation. Okay. Just make note of this calculations. So, so few of the online classes are being recorded and it is being uploaded. The link of the same is being shared in the WhatsApp. So you can just go through the same link and try to see that you're studying each of the topics daily. So, all right. So, what is the interpretation for this? Total float for 1-2 activity is 0, which means that there is no delay available for this activity. Okay, there is no delay available for this activity. 1-2 activity has to start on the 0th day. Okay, that is the meaning. But similarly, if you have to see, activity 2-3 activity has a total float of 6 days, which means that this activity can start anywhere in between 7th and 13th day. Okay. In case if anyone has not understood any of the concept, you can just ask, or you can put the message in the chat box. Okay, so once this is done, activity 2-3 has a delay of 6 days, which means that this activity can start anywhere between 7th and 13th day. Okay, that much of the delay is there for the project manager. Okay, that is the reason. So we can say that this is a non-critical activity. In other words, why? Because by delaying this activity, we are not having any type of delay in the project completion duration. Is it right? So this also can be called as non-critical activity. This activity can also be called as a non-critical activity. not only this activity, any activity that has the delays available with it, it can be called as a non-critical activity, while the first activity 1-2, that can be called as a critical activity because there is no delay available at all. The project manager has to start on dot of time. Okay, on the first day itself, this activity has to be started. Okay, so I believe that everyone has made note of this. All right, so can you tell me the rest of the activities? Activity and total float 1-2 0, 2-3 6. Next
3 dash
3 dash
5.
3-5. Okay,
Dash 4.
how much?
2 dash 4.
Okay,
4 dash 5.
okay. What is the next float here? And how do you calculate it?
27 minus 21.
27 minus 21 is 6. Okay, next
22 minus 22.
22 minus 22 is 0. Okay,
27 minus 27.
27 minus 27 is equal to 0. So you can say that these three are critical activities. Okay, is it right? So you have already studied critical activities. Is it right? Critical activities means what? By delaying these activities, the project completion duration also will be delayed. So those are called as critical activities because total float is 0. Okay. These are non-critical. Okay, is it fine? Because total float is non-zero value. That means what? By delaying these activities, the project completion duration will not be affected. Okay. These are the critical activities 1, 2, 4, and 5. 1-, 2-, 4-, 5 is the critical path. So I think for this particular topic, that is total float topic, I don't think a practice problem is necessary. We'll go for the next topic, and along with that topic, we'll discuss. We'll have one extra practice problem on this topic as well as the next topic. Okay. So for this problem, I don't think a practice problem is required since this is very much simple. We have to just subtract the two values, that is the date start and the early start. We'll get the total. Here, the interpretation is the major component here. We should know how to interpret total float. Okay. So that possibly is made very much clear. If there is any doubts, you can ask. Otherwise, we'll go for the next. Possibly the next topic requires some more concentration. So we'll have to concentrate a little more for the next component, determining the early start. Make note of this. Okay. So in case anyone wants me to go back to the previous screen, you can ask me to do so. All right. So once this is done, next we will discuss the early start. Sorry, not free float. So this float is a part of this float is a part of the total float. This float is a part of the total float. Okay. Uh, to determine the free float, the project manager assumes that the present activity finishes on its early finish date. Okay, it's like this explanation. So here the project manager is assuming that the, the current activity will finish at its early finish date, and the next activity will start on the early start. Okay, so just make note of this. And we will go for the next. Okay, so we'll go for the next one. Present activity finishes early finished. Just a minute. Yes, the early finish date and assume that the present activity finishes on its early finish date, and the next activity starts on its early start. Right? So this is the basic assumption. Early finish date and the next activity, we assume that the next activity will start on its early start date. Okay. So this is basically the assumption while calculating the free float. So that may happen, is it right? So the current activity may finish as soon as possible. The next activity may start as soon as possible. So in that case, or the project manager may be willing to start the next activity as early as possible. Why this is the case? Because if the project completes early, it is good for the project manager. Why? Because that much of the time will be saved, and if the time saves, the salary and the indirect cost like electricity, uh, incentives will be saved. Like the project manager need not have to pay on all this. Is it right? So this is something of important concept, correct? So that is free flow basically. So I hope everyone has made note of this, or everyone has understood this concept.
Yes, sir.
So only one calculation we will try to do today, only for one activity. Then we'll continue with the next class. So right at the next page. Just make note of this, right? And okay, so we'll just go ahead. So what we are supposed to do here is consider one example. We consider an activity 2-5, 5-6. Okay. Early start and other details are as follows. Okay. 2-5. Third column of activity. Okay. So this is sufficient for our calculation 2-5 and 5-6. 2-5, let us assume that and 5-6 has the early start as 8. Okay. So after calculating or after making some calculation, let us assume that this is the scenario wherein we have the early start for 2-5 activity as 2 and early finish as 5. Or also we can say that this is 2nd May, just to see that it is looks realistic. This is 8th of May and 12th of May. Okay. Now we have to determine the free float. Okay. So determine the free float for this 2nd May and 5th May, 8th May and 12th May. So for activity 2-5, specifically they have asked only for 2-5, yes, determine free float. Okay, so possibly just keep this question and we'll discuss this in the next class. Okay, so we'll not go ahead. So just make note of this question and we'll discuss this in the next class. So the class years can just send me the list of absentees.
Yes, yes, sir.
Okay.
3 people. Sir.
Three of them.
3, yeah.
Okay. So thank you. Others
Yes, sir.
can, who are yet to write this question, they can still remain in this screen. Others can leave. Thanks.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank
Thank you, sir.
Thank you, sir.